Welcome back to Talk Tensors. You know we love to take these deep dives, and today we're looking at reward machines for deep RL in noisy and uncertain environments.
Yeah, this is a cool paper.
It really is.
It's all about making AI agents, more robust when dealing with the real world.
Exactly. Like,
Right.
how can we get them ready for the chaos of reality?
Exactly.
And,
Yeah.
we're excited to break this down.
Absolutely.
So how do they propose to do this?
So they use reward machines,
Okay.
which are kind of like, you can think about them as like blueprints that guide these AI agents on how to complete tasks.
Okay.
So like imagine you're following a recipe and each step has a reward for following it correctly.
Right.
That's kind of like a reward machine.
That makes sense, like a roadmap for AI success.
Yeah.
But we're not talking about a perfectly predictable world, are we?
No, definitely not. And that's where things get interesting.
All right.
The paper goes into how to make these reward machines work even when things are uncertain. Like think about a self-driving car navigating a busy street. It might encounter a sudden detour or a pedestrian.
Right. Like the AI needs to improvise on the fly.
Exactly. And to help the AI deal with this uncertainty, the paper introduces abstraction models.
Okay.
And you can think of this like giving the AI agent like a basic understanding of the world before it even starts learning.
So it's not starting from scratch. It has some context.
Yeah, exactly. Like giving a robot a rough map of the kitchen before you ask it to bake a cake.
Perfect analogy.
These abstraction models, they can be anything from simple sensors to complex neural networks.
Oh, yeah.
They're essentially giving the AI this framework to interpret the world even when the information is a bit messy.
Okay, so we have the reward machines, which are like the instruction manual.
Yes.
We have the abstraction models giving it context.
Right.
How do they actually make these things work in a noisy and uncertain environment?
So the paper explores 3 different approaches, and the first one is called naive,
Hmm.
which basically takes the output from the abstraction model at face value. So it's like, okay, I'm going to trust this information completely and base my decisions on it.
But wouldn't that be risky if the information from the model is wrong?
Yeah, you're absolutely right. And that's one of the big limitations of the naive approach. Like, think about the gold mining robot. If it mistakenly identifies pyrite as gold,
Right.
then it's going to waste a lot of time digging in the wrong spot.
Oh, yeah, like one error leads to a bunch of bad decisions.
Exactly, like a domino effect.
So what about the second approach, independent belief updating, IBU?
Right.
How does that handle uncertainty?
So IBU tries to be a little more cautious. It considers like multiple possible interpretations of the world.
Okay.
It's like, okay, there's a chance this is gold, but I'm going to keep an open mind and consider other possibilities.
So it's more flexible,
Exactly.
less likely to get stuck in a rut.
Great. But it still operates under this assumption that each prediction from the extraction model is independent from the others.
Okay.
And this can work in some cases, but in many real-world situations, these predictions are actually linked over time.
All right, it's like thinking if you flip a coin 10 times, you'll get 5 heads and 5 tails.
Exactly.
When in reality, there could be streaks.
Exactly. And that's where the third approach comes in temporal dependency modeling, or TDM.
Okay.
It recognizes that these predictions over time are often related, and it tries to account for those dependencies.
Okay, so before we jump into TDM, I think it would be helpful to give our listeners some historical context.
Yeah, absolutely. So the use of like formal languages and reward machines
Right,
has a long history in AI research, especially in sequential decision making.
right.
Early work in this area was focused on simpler scenarios, like where the environment was fully observable.
Yeah,
Think about navigating a maze.
Right.
Everything's laid out in front of you. There's no hidden information or unexpected changes.
but AI has progressed. Researchers have tackled more complex and uncertain environments.
Exactly. And that's where the need for methods like TDM,
Right.
which can handle all this noise and uncertainty, becomes crucial. It's all about bridging the gap between the theory and these real-world applications.
So this paper is pushing the boundaries of what's possible with reward machines by making them deal with real-world uncertainty.
Exactly. It's a significant leap forward in making these reward machines more robust and reliable.
This is all fascinating.
Yeah?
I'm eager to hear more about how TDM works and how it did in the paper's experiments. But let's save that for part 2.
Sounds good.
See you soon.
See you then. Welcome back to Talk Tensors. So last time we were talking about reward machines for deep RL in noisy and uncertain environments.
Right, and we had just touched upon that history of sequential decision-making in AI.
Exactly.
We talked about reward machines, the instruction manuals,
Yes.
abstraction models, giving the AI some context.
Right.
And we even started talking about the naive and the IBU approaches.
Right. So let's dive into the star of the show, temporal dependency modeling, or TDM.
Okay.
Remember how we talked about IBU assuming that each prediction is independent?
Yeah.
Well, TDM says, nope, not so fast.
It acknowledges that the world doesn't just reset, what you observe at one point in time
Yeah,
can greatly influence what you observe next.
exactly.
It's like, realizing that if the robot didn't find gold in one spot,
Right.
it's probably not going to be there on the second try.
Precisely. TDM is really designed to learn those relationships, almost like building a memory of its past experiences
Okay.
to inform its current decisions.
So it's considering the bigger picture, the context.
Exactly.
That's really cool.
And the paper's experiments really highlight this power.
Mm.
They tested these different approaches in a bunch of different environments, from a simulated gold mining task
Yeah.
to navigation problems in visually complex scenes,
Wow.
and even a robot car task that involved color recognition.
They really put these methods through the ringer.
Yeah, they wanted to see,
Did TDM live up to the hype?
And it really did in almost every case. TDM significantly outperformed the naive and the IBU approaches.
Nice.
It was even able to achieve results comparable to an Oracle agent that had perfect knowledge of the environment.
So like it was almost cheating.
Almost.
That's impressive. So TDM really seems to be a game changer when it comes to handling this uncertainty.
Absolutely.
What about those other approaches? How do they do?
Their performance was a bit more inconsistent.
Okay.
Sometimes they did okay, particularly when the assumptions about the environment happened to hold true.
Right.
But when those assumptions broke down, they really struggled.
That makes sense. It shows that you can't oversimplify things.
Exactly.
Can you give us some concrete examples of how these approaches played out in the experiments?
Sure. Let's go back to that self-driving car navigating traffic lights
Okay.
with the obscured views, remember?
Yeah.
Well, that naive approach, just trusting that potentially flawed information, often led to the car running red lights.
Oh, no, that's kind of scary.
It is. It's a good reminder of why it's so important to handle uncertainty correctly.
Yeah, especially in the real world.
Right. And think about that kitchen environment where the AI had to complete these cleaning tasks without knowing which ones were already done.
Right.
The IBU approach, with its independent predictions, often got stuck in a loop, repeatedly checking already completed tasks.
Oh, like that person who keeps checking the stove even though they already turned it off.
Exactly.
Right.
TDM, on the other hand, by understanding the relationships between those tasks,
Yeah,
was able to navigate the kitchen much more efficiently,
that makes sense.
prioritizing actions based on its evolving understanding of the world.
So it's not just reacting to immediate observations, it's learning and adapting.
Precisely.
That sounds a lot like human reasoning.
It's a great observation.
Yeah.
These examples really demonstrate the importance of designing AI systems that can reason about time and uncertainty.
Right.
They need to be able to learn from their experiences and adjust their behavior accordingly, just like we do.
This brings up a really interesting question, though. If TDM is so good at these time-dependent predictions, what if we could augment it with something humans are exceptionally good at? Like long-term planning and reasoning based on a lot of accumulated knowledge.
That's an interesting idea. Imagine an AI system that could not only learn from its own experiences, but also tap into this vast database of human knowledge.
It's almost like combining the best of both worlds.
Right.
The speed and processing power of AI with the wisdom and insight that humans have built up.
Exactly. Imagine that self-driving car having access to real-time traffic reports, social media posts about road conditions, even weather forecasts.
It's like having a co-pilot that knows everything.
Exactly. That's the power of this human-in-the-loop approach to TDM.
Really interesting.
It's about bridging that gap, between the machine learning from data and the human capacity for reasoning and planning.
It sounds like a really powerful concept, pushing the boundaries of what's possible with AI.
Absolutely. And this paper really lays the groundwork for such advancements.
Okay.
It demonstrates that we can build these AI systems that are more robust and reliable in the face of uncertainty. And this opens up a whole world of possibilities for real-world applications.
Well, I'm excited to see where this research leads, but for now, we'll have to wrap up this part of our deep dive.
Okay.
Stay tuned for part 3, where we'll explore even more novel notions inspired by this paper. Welcome back to Talk Tensors. We've been spending this episode really digging into this paper, Reward Machines for Deep RL in Noisy and Uncertain Environments.
It's been a good one.
Yeah, it's a fascinating paper exploring how to make AI more robust in the face of real-world uncertainty.
Absolutely.
We've seen how TDM helps AI learn from those past experiences to make better decisions in the present.
Yeah, like building on its own knowledge.
Exactly. It's almost like how we use our own experiences to, figure out the world.
Right, and as we've been talking about, this paper really opens up some exciting avenues for new research,
Totally.
especially in areas where AI needs to work in these complex environments.
Absolutely. Now, before we wrap up completely, let's shift gears a bit
Yeah.
and head into our novel notion segment.
I like this part.
Yeah, where we get to explore some of those speculative but plausible ideas that this paper kind of sparks in our minds.
The what ifs.
Exactly right. So we've talked about AI learning from its own experiences and even maybe tapping into human knowledge.
Right.
But what if we take that even further?
Okay.
What if we could create AI that not only understands the world, but can actually imagine alternative possibilities?
Like coming up with its own ideas.
Yeah, envisioning scenarios that haven't happened yet.
That's a fascinating concept.
Right. It's like getting into the realm of imagination and creativity, qualities that we typically think of as uniquely human.
Uh-huh.
Like imagine an AI architect
Okay.
that can not only design buildings to meet our needs, but also predict how those needs might change over time.
Wow.
Or an AI scientist that could run tons of experiments in a virtual world to speed up discoveries.
We could really accelerate things.
Exactly. The possibilities are huge.
They are.
But as with any powerful tech, we've got to be careful, right?
For sure.
AI that can imagine things could also be used to create, super convincing deepfakes.
Right.
Or manipulate how people see things. So it's important to keep those ethical implications in mind.
Absolutely. A good reminder that as we try to make AI smarter and more capable, we've got to prioritize those ethical considerations.
Yeah. It's not just about the tech itself, but how we use it to benefit humanity.
Well said.
This paper, with its look at reward machines in those uncertain environments, really gives us a peek into a future where AI can really thrive in the real world.
Yeah, taking on all that complexity.
Exactly. For those of you listening who want to check out the nitty-gritty details of the paper,
All the technical stuff.
yeah, we'll include a link in the show notes.
It's a really interesting read.
And as always, we love to hear your thoughts and reactions to this paper.
Definitely.
So feel free to reach out.
Let us know what you think.
From all of us here at Talk Tensors, thanks for joining us on this deep dive.
Thanks, everyone.